Today we're going to be converting fractions greater than 1 into mixed numbers. Fractions greater than 1 is the updated term for improper fractions. There's nothing wrong with an improper fraction, so it was the wrong term. So we're going to call it what it is, and that's a fraction greater than 1. So the first fraction we're going to look at today is just going to be a simple fraction like 4/3. We can tell that 4/3 is a fraction greater than 1 because our denominator tells us that it takes 3 parts to make one whole, and we have 4 of those, and that's what our numerator tells us. The easiest way to convert these fractions is for us to think of this as a division problem. So let's change this so that it's 4 divided by 3. 4 divided by 3. Now, 4 divided by 3 is equal to 1, remainder 1. Okay. But let's now convert 1 remainder 1 into a fraction. This case, it's going to be a mixed number. So we have 1 whole, we have 1 leftover part, and then we come back to this denominator over here to see how many parts it takes to make a whole. We see that it takes 3, so it becomes 3. All right, let's look at another example. Slide my paper up a little bit. Okay, let's take a look at, let's say, 5 halves. All right, so let's convert it to our division problem. 5 divided by 2. 5 divided by 2 is equal to 2, remainder 1. Then we're going to continue. Now we're going to change it to a fraction. We have 2 wholes, we have 1 as our remainder, and it takes 2 parts to make a whole, so we keep that denominator the same, and we put a 2 there. I'm going to do one more example, and then I'm going to show you one other part to this. Alright, slide this up a little so we can still see it. Let's try the fraction 7, let's say, fourths. Alright, now 7 fourths is going to be 7 divided by 4. Which equals 1 remainder 3. This 1 remainder 3 shows 1 whole, 3 extra parts, and then it takes 4 to make a whole, so it becomes 1 3/4. For many 4th grade scholars, division with remainders, especially with these basic facts, can become a bit of a challenge. So I'm going to use this example here, and I'm going to show you what you can do to help your scholar at home to help them figure out these division problems. All right, so we can see here we have 7 parts. So if we just draw the 7 parts, just as little sticks, 1, 2, 3, 4, 5, 6, 7. Great, okay. And we're dividing them into groups of 4. If we think about the actual fraction that this represents, right, we have 1 whole here with 4 parts, 1 whole here with 4 parts, and we have 7 of them. 1, 2, 3, 4, 5, 6, and 7. Now, if you look at these, doesn't this look like a group of 4? And then we have a group of what would be 4, but it only has 3 parts? That's kind of what we're going to do here with our quick sticks. We're going to say we're dividing into groups of 4. Look, I made one group of 4, and now I can't make another group of 4, so I can see that these are the 3 leftover parts. This is that right here, and this part is this here. So you can have your scholars at home draw this quick diagram to figure out that it's 1 remainder 3, and then they just need to put it just like that. Let me show you one of the examples that we have up here of what it could look like on a scholar's paper. Alright, so we have 5 parts, 1, 2, 3, 4, 5. It's divided into groups of 2, 1, 2. And now look at that. We have our 2 wholes, and we have our 1 part left over. Same thing up here, 1, 2, 3, 4. Groups of 3. We have our 1 whole and our extra part. Alright. Now what part of this do I expect to see on scholars' papers? If they wanted to convert, we'll do one more example and I'll show you what it would look like on a scholar's paper. If they want to convert, all they need to do, let's say that we're starting with a fraction, let's just do 3 halves, right? 3 halves? If I was a scholar, I'd be thinking to myself, 3 divided by 2. 3 divided by 2 equals 1. It has a remainder of 1, and the denominator for my original fraction is a 2, so I'm going to keep that as a 2. And that's all there is to it. That's the way that we expect scholars to do it. Now, they might do things like a number bond, so you might see your scholar write 3/2. Circle it here. Show that they have the 1 whole, 2/2. And they have the 1/2 right here, 1/2. And we can check our work by doing 2 plus 1 equals 3. All right, and we know that this is equal to 1 whole. This stays as 1/2. And look at that. 3 halves is equal to 1 1/2, and that's what we have here. So there are a few different ways that a scholar could have shown it. I'm sorry that you weren't able to see that. There it is. All right. There are a few different ways that a scholar can show it. My recommendation is actually for them to show pretty close to this whole thing, is if they were to make a mistake, I can still award them credit for heading in the right direction. All right, as always, if you have any questions, please reach out.